Right. Is everybody ready?
Yeah!
So we're going to talk about something that you can see every day.
Science.
Yes, you do see science
And
every day.
carbon dioxide.
Yes. Carbon dioxide has been used for this. So in the past, we've talked about solids, liquids, and gases. Another thing we talked about was magnetic attraction or repulsion. Today, we're going to talk about something that you guys have all seen with your eyes. Right now you're seeing it. Light and color. Look at the lights. Do you guys know how those work? Oh, well then if you know, then okay. I'll see you guys later. But let me get more into it. So when you see light, what that is called is incandescence.
Incandescence?
Yes! Does anyone have a stove at home? Does your stove have fire, or is it like a circle thing like the toy over here? The circle thing, does it get really hot and red when your mom or dad is cooking?
Yeah.
That is an example of incandescence. Something gets really hot and it glows a red color. The sun is an example of does partial incandescence. A lot of other things goes on in the sun. Yes.
No. Yeah, but we're talking about paint.
Yeah, we're talking about paints. So you're wearing a red shirt, correct? But the light in the ceiling is white. How are we seeing this red color?
Your jacket's white. No.
My jacket's white. So when you see white light, like this flashlight, right? The flashlight's white. Do you know what the flashlight and the light and the sun? They're emitting every single color at the same time. Can anyone tell me the eight main colors of the light, or the colors? All right, let's do it together. We got red, orange, yellow, green, blue, indigo, and violet. But white is a mixture of all the colors. So, with your red shirt, what's happening is all the white light is absorbing into your shirt, except for the red. The red color is bouncing off your shirt and into our eyeballs. Just like your purple shirt. All the white light is absorbing into your shirt, except for purple, which is bouncing to our eyes. Same with the pink and the green, the yellow. All that is, every color you see, the white reflects the white back. Black absorbs all the colors. It's the absence. So when you see black, what's happening is all the colors are absorbing and none are reflecting back to your eyes. Isn't that amazing? Everything you see is because it's being reflected. Do you guys want to see all the colors from the white light? So this is called a prism. What happens is, Sam, I need you to sit down. It's actually just a triangle, but it's a three-dimensional triangle. So like a ball, it's a circle, but you can rotate it, and that's called a sphere. This is a triangle that's in an oblong shape, and it's called a prism. And what it will do is you shine white light through it, and it will split off to all the colors. Yeah. You guys ready?
Yeah.
All right. So here's the white light.
Oh.
All right. I'm going to turn the light off real quick.
There's red.
Just look what he's doing.
Can you all see the colors? We got red on the very far edge. It's a very thin line. We have orange. We have yellow next to the orange. This is a very faint green, but it's green.
There's red.
What's after green?
Blue.
Correct. Then there's blue, and then there's a
Purple.
in between the blue and the purple. It's called indigo.
Blue.
And then violet, yes, or purple. So, you guys, you want to see something?
Yeah.
So you see how much white light is coming out of here?
Yeah.
So just for the sake of the discussion, look how small it is now. It's a tiny little rectangle, correct?
Yeah.
Do you know that the sun in light emits so many different colors, but we can only see this small amount? So you have a... So does anyone have a TV remote at home? Yeah! And your mom or dad are sitting on the couch or from a distance and they're able to change the television? You know, there's nothing connected to the TV. What it's using is called an infrared light. Can you see infrared? No. It's actually, if this is red, infrared would be right here. You can't see it. Has anyone ever heard of ultraviolet or UV light? Oh, don't touch it. Has anyone ever heard of UV light? Do you guys go to the pool or the beach? Does your mom or dad put that white lotion all over and you're like, I just want to get in the water, and they're like, oh, I have to put the lotion all over you? Oh, I hope so. Yeah, so you just go like this. Because the sun, which is emitting all of those lights, is called ultraviolet. And it is on this side. You can't see that either. Well, there's a bunch more. You start to get into, does anyone know how the Incredible Hulk was made?
There's some orange on the light.
There's some other more intense radiation like gamma and alpha and beta. Those are fun words to say. But those are get more out here. They're very intense. The infrared, you start to get over here. Then somewhere in this line you get microwaves. Does anyone have a microwave at home? Yeah, microwaves are fun. Yeah? You have a microwave? So it's actually emitting a spectrum over here. It's far away from the red. And then you get, does anyone listen to the radio in the car?
Yeah!
That's even further out here. It's crazy how much light you experience all the time. Do you know what the technical term of light is?
Yeah!
Let's see if you can say it with me. Electro.
Magnetic.
Spectrum. Let's say it all together. Electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic spectrum. So last time I was here, we talked about magnets, correct? This time we're talking about the electro part. So if this is light, how does that deal with magnets, right? So if it's called electro and magnetic spectrum, where is that magnet? Can any of you do this for me? This is called a right angle. So you have the electro part, or the light part. At this bottom part is the magnet. Yeah, so this is how it operates. It's always like this. It's at right angles to each other. Or a fun word is orthogonal. But don't worry about that. We're not going to talk about that. So, if this is the light. What's another fun thing that you guys know about light? Have you ever heard of a type of light called a laser? A laser.
My uncle has a laser gun.
Whoa! Well, I have a laser right here. Do you know what a laser is? So this specific laser is going to shoot off a green color, just like your shirt. Well, your shirt's red. Yes.
My shirt's green.
So, what it's going to do, the flashlight emitted what? White, right? So it emitted all the colors. This is only going to specify one specific color. Look how thin it is. This is the green,
I can't see.
and this is the white.
What?
Look how much thinner the green laser is versus the white. So the white, in the flashlight, it goes everywhere, while the green is very narrow, like an arrow. Very pinpoint. So, you guys want to, let's see if I can do this while holding it. Can you guys, from the back, are you able to see the little line that goes through the prism?
It's on the wall. It's on the wall.
Try to make sure it doesn't reflect anyone's eyes.
Yeah. Look on the wall.
See how it goes through? So this is another type of light, but it's only a very specific color. It's very intense. So what is one safety thing when we have flashlights? Do we point flashlights at people's eyes? No, it can really hurt. Because having all of that light go into your eyes can actually start to cook it and burn it. And then you won't be able to see anymore. So we don't want to do that. Never put a flashlight in the eye. What do we never do? Excellent. So, what are different types of ways to make light that we know? We know incandescence, right? That's what the oven was. That's what the sun kind of does. Evan, yes, sir. Can you go sit down? Wonderful. There's other things. Has anyone heard of a firefly or seen a firefly?
Yeah.
Does it light up?
Sam, sit down.
That is actually something in the animal.
Ready, wait a minute, you guys, make a bubble.
Bubbles in your mouth.
So a firefly actually creates a reaction in its body that lights up, and it's called bioluminescence. That's a fun word to say. There's also something where you can do a chemical reaction, which I'm going to show you guys today. It's called chemiluminescence. There's also electroluminescence. Has anyone ever seen lightning? I know we're in California and those don't happen very often. But have you ever seen lightning? Yeah, it comes from the clouds and goes right, and it's super bright. Do you guys know what color that is? It can be yellow. It's more blue or purple most of the time. Do you know what makes those colors? Do you know why it's either yellow, blue, or purple? Because so the way electricity works and light, you get all this static energy up in the clouds, and then all of a sudden it has to go somewhere. So it goes to the ground. And as all this electricity goes through the ground, it starts reacting with the different things in the environment, like carbon dioxide, like nitrogen, and because it hits those different elements, it changes colors. The majority of our planet is filled with nitrogen, which is why primarily your lightning is a blue-purple color. So, the next thing I want to show you guys is the iodine clock experiment. But Evan, I'm going to need you to sit back, okay?
Sam, sit back.
Or Sam, I'm sorry. Sit back, Sam. You have to go on the carpet. Because, are you wearing any safety equipment right now? Exactly. This is what you do when you do a chemistry experiment. You always make sure you have your safety stuff. You have your glasses, you have your gloves, and you have your lab coat. Oh, no, I'm not a physician. Don't worry about that. So, what we're going to do.
Let's see what's gonna happen. What's gonna happen?
Let's
Lauren, sit on your bottom. Felicity, sit on your bottom. Everybody needs to sit on your bottom because people can't. Josiah, sit on your bottom. Felicity, sit on your bottom.
Yep. So when you do a chemistry experiment, One of the most important things you should always do is document or write down what you're doing so you can always look back and remember. So, the first thing I'm going to want to do is get some water. This is my measuring cup. Chemistry is a lot like cooking. You just measure things out, you mix it together, and voila, something fun can happen.
And explode?
As long as you're safe. So this is asking for 10 milliliters of water.
You're gonna put that inside?
I'm going to put it in a cup, so that's just water. Ooh, we're about to find out. The next it says, I need some sodium iodate. That's this stuff. You guys want to say sodium iodate with me? I'm going to wow you and amaze. Hopefully spark curiosity.
You can make a prediction of what you
What do you
think
think's
is going
gonna happen?
I
Blow up?
I think it's
I think it might bubble, change color.
maybe he was talking about colors
He
earlier.
was.
Yes.
We're going to make this big only because it's more. That's my word. All right. So the next step, I'm going to do that part last. We need some small amount of manganese sulfate. See, these words are not intimidating. They're just fun. They're just different, right? So you never want to cross-contaminate. So other types of light you guys have at home? You guys ever have a glow-in-the-dark t-shirt? Yeah?
I have one.
You have one glow-in-the-dark t-shirt.
I have one.
You have one? So do you know how that shirt works? Or like sometimes there's stickers or toys that glow in the dark. When it's dark, you can see they're all lit up. That's another term of luminescence or light. That's called phosphorescence. And what happens is, so the way you see light, other than it going directly to your eyes, is there's a molecule. Remember, we did the whole gas, liquid, solid. So you have this molecule. Let's just say it's a solid, right? Because your shirt's it's a solid. It's not a liquid or a gas, right? So it's just solid is sitting there. And all of a sudden, your mom or your dad or yourself, you put light onto it, right? Because that's how you're supposed to charge it. And what that does is, it gets that solid a little more excited, but it's still a solid. And it gets a little bigger, and then it likes to go back to its comfort state. So it gets all excited, and then it emits light. And that's why you see it. The technical terms are excitation and emission. I'm working on it. All right. 3 to 4 drops of starch solution. Let's do one more. Let's do 5. Let's make it fun, right? So what is this called?
Chocolate syrup.
This is called hydrogen peroxide. This is has anyone had an owie and their mom or dad puts this on and it kind of like stings a little bit or bubbles? Have you seen the bubbles? Yeah, that's just a little chemical reaction that happens.
At my dad's house, he has it.
Yeah. It's a little chemical reaction. Those bubbles, you know what those bubbles are? It's just oxygen. It's nothing to worry about. It's just oxygen. Yeah? All right. All right. All right, we used 10 mils. Not very much. Let's see what happens. So we're mixing the solutions, right? It's okay. Let's see what happens when I mix them. You guys ready? All right.
My cooking sometimes.
What is it? See, that's science.
And this happens quite often in
What
science.
it is, what's going to happen?
On your bottom.
Now I'm going to get crazy.
Page.
This is what I do.
Right down.
Whoever's doing that, please stop making that noise.
Yes, I am.
Billy, sit down, honey. Dad.
So pulsing. Or at least one ingredient. I get it. Like, I do that all.
They make it look so easy on television. There we go.
It's like a TV.
Okay.
Look at it. Ooh, look.
What?
What?
Whoa.
What happened to the color?
It was white. It was clear.
No, this
Then it turned a little like cloudy.
purple.
And look what's happening.
What's happening?
It's okay.
That's so cool. Yeah, I wish I could.
So I made a change just to one side, but I'm trying to get it back to the other.
Want to get down, Sammy?
There we go.
Watch this.
Watch it.
Magic.
Oh,
My two boys.
they're going to be on Lucy's class next week. Okay, you guys need to go sit.
All right. Well, I got to change from one color to another. In theory, you're supposed to go back and forth, back and forth.
That's okay.
So, well, this does happen in science experiments sometimes. You do get a reaction. Sometimes it's not the reaction you want, but you always get something. And then you have to figure out why it did do that. And then you discover more. So I'm going to put this aside because we got a couple more things I want to show you real quick. Does anyone know what these are? What this is?
I know what those are.
So you want to know a fun fact? There's two types of things in this world that we have seen that got me super interested in science. One, being fireworks. Does everyone like fireworks? Do fireworks have different colors? You guys know how those colors work? Oh, okay. Why am I even here? You guys all know this. So, a way a firework works is The way fireworks work is they fly up in the air, right? Then they explode. And they get so hot, each firework with different colors. Has anyone seen a blue firework?
Yeah.
Yeah, do you know what makes it blue? There's copper in there. Just like a penny, right? A penny's copper. Or the Statue of Liberty. It's copper. So it lights up the copper and it makes it blue. Has anyone ever seen a yellow firework? Do you know why it's yellow? Because it has sodium in it. The sodium makes it yellow. Has anyone seen a red firework? Do you want to know what makes it red? Strontium. That's a fun word to say. See, chemistry is fun. It has a lot of fun words to it. So, the other thing that got me interested in science were glow sticks. I never really understood how they worked. And yes, I'm going to promote LSU, because that's my school I went to. This is a glow stick, right? You just break it or bend it, and all of a sudden it lights up, correct? But do you guys know what's in here that makes it light up? There's two chemicals. There's one on the outside, and then there's a little glass vial in the interior. So, what I'm going to do... Sorry. Can you sit down?
Stop.
I'm going to cut this open.
Look it, we're gonna watch. What's gonna happen?
And it's already started. Can you all see the very faint blue as it trickles in?
Sit down, honey.
You have to sit down.
Finley,
You have to
sit
sit down, Finley. No, it doesn't explode. What's happening is, you're mixing these two chemicals together. The exterior is called luminol. And the interior, the one that's in a little glass vial that makes a little crack sound, is hydrogen peroxide. Don't put this on everything. Luminol.
Is that the one they use at
And forensics.
Yeah?
Yep.
Okay.
It's the exact same.
Look at you, Elisa. CSI.
So what happens is when they mix it in, do you remember what I talked about with the solid state? And all of a sudden it gets a little bigger, and then it goes down again, and then it emits light? Well, now it's like the liquid. The liquid is just flowing, and all of a sudden, yeah. And then it gets a little bigger, and then it goes back to the normal state. And then it emits a light. And that's how chemiluminescence works. There is no smell. And they have made these a lot stronger than they used to.
Is the luminol different colors? Or is it only that?
Luminol is blue. So there are other colors out there, and they use different chemicals for different colors. So, since this is going to cut easily, and I'm in the interest of time, can you all see it?
Oh, let's let them watch him.
Let's see if I can get that flashlight. See if you can see the... It's kind of hard to see, I guess, unless you're right up here. Maybe the laser. Can you guys see the two bubbles? So those two bubbles is representative of two things inside here. Or one, there's a liquid in the exterior, and another one in the interior. Once there's that chemical reaction, wait, listen. Can you guys all hear the crack? Did you hear that? That means I just introduced hydrogen peroxide to luminol. And what is this light called? This is blue. But what's the technical term of all the lights? Is it called remember? The electromagnetic spectrum. So electromagnetic spectrum. So the very last thing where I'm going to have you guys all do is talk about one more thing. This ball. Does anyone know what this is called?
A light bulb.
It looks like a light bulb, but inside here is a pure atmosphere, pure air. That little gray ball is going to get a lot of energy.
I want to know what it is.
Watch. What's going to happen, Kyla?
What's going to happen when I turn it on? Can we all see that? I will let you touch it eventually. So what's happening is, it's creating a little electroluminescence inside there, like lightning. So what color is it? What color do you see? There's red on the exterior, but what about the lines? What color are the lines? That is the color of nitrogen.
Evan, wait.
Just like this is the color of luminol. In fireworks, strontium is red and sodium is yellow. Nitrogen is like this blue, purplish color. So, if you touch it, all it's trying to do is complete a circuit. This is another time for another experiment. But it's an electrical circuit. But you can see the color now, huh? A lot better. So, does everyone want to touch it? Yeah! All right. Does anyone want a glow stick? Yeah! Is that okay? Later?
Yeah, maybe. Yeah, I think it's okay.
Okay. All right. So let's form a line.
Everybody go get mine. Go get mine. Everybody get in a line right here. Form a nice line.
I will leave the glow sticks with your teachers, and you guys can get it afterwards. You ready?
Go get
Touch
mine.
it. I just couldn't be able. All right, move on, Evan. Is that fun? So it's like you're conducting the light.
After they touch the pen.
So what was the name of it?
So the line.
Get in a nice line.
You gotta get in line. You get a stick after you touch. Come here, Steve.
You can get this at Walmart. It's $20.
That's what I want to do.